Welcome back again. This is our video solution to problem 4 from Superquiz 3. In this problem, we're going to be computing the curvature of a curve parametrized by some vector function at a particular point t equals 1. Again, by specifying a particular point, it'll make some of our calculations slightly easier, although this one is not nearly as challenging as the t and b frame would be without giving a specific t. So in this situation, we're going to use a very easy formula for the curvature. So curvature is usually denoted by the Greek letter kappa. And it's given by taking the magnitude of the cross product of the first and second derivatives of the parametrizing function r. And then we divide that by the cube of the magnitude of the derivative of r. What an obvious formula. So in order to use this, of course, we're going to have to start computing some derivatives. So why don't we get at that? So the derivative of r is going to be 2, 0, 2t. Right? So we'd be a little careful. When things get too easy, occasionally we make some pretty silly mistakes. Easy thing to do here is to take the derivative of 1 and just write 1 again. Right? This happens quite a bit. So be careful with these easy derivatives. Then we take a second derivative, and okay, this is even easier, right? Again, don't just keep it 2 here, right? The derivative of a constant is 0. So we get 0, 0, 2. Now, I'm going to have to take the cross product, but before I do, let me actually evaluate these at t equals 1, just to get all this one little t out of the game. So when I evaluate at t equals 1, I get 2, 0, 2. And well, actually nothing actually simplifies it down here because there were no t's anymore. It's still just 0, 0, 2. All right, now I want to take a cross product. So I'll get r prime at 1 cross r double prime at 1. And okay, so I can line this up, cross off the first column, and I get 0 minus 0 is 0. Cross off the second column and go backward. I get 0 minus 4. So that's minus 4. And then I cross off the third column and I get 0 minus 0 is again 0. Let me quickly go through this alternative approach, which I also like very much, particularly when the vectors are this simple. So we could rewrite the original r prime of 1 as 2i plus 2k, and r double prime of 1 as 2k. And so the cross product of r prime at 1 and r double prime at 1, well, using distributivity is going to be, let's see, 2 times 2 is 4 I cross k, plus, okay, 2 times 2 is 4 k cross k. And k cross k is 0, right? Anytime you take a vector cross itself, you get 0. To get I cross k, well, we should always have this picture in our mind, where we say, okay, you go around it, and if you do see ij, you'd get k, but oh, we want ik, so you go backward, actually, it's in the opposite direction, so I with k is going to be negative j. Okay, so we end up with 4 times negative j, or negative 4j, which we see we could have written the vector we computed in the alternative method in that same way, negative 4j. Once you get this picture sort of embedded in your mind and you don't have to think anymore, you just say, oh, whenever there's a duplicate, I just ignore it. This actually is a really fast method. Like I would have looked at this and immediately just said, oh, all I need is this. Okay, that's 4, negative j, negative 4j, right? Very, very fast. In any case, we also, of course, are going to need the magnitude of negative 4j, but that's very, very easy. Whenever you're pointing in one of those 3 directions, ij or k, and that's it, right? Then the magnitude will actually just be the absolute value of this constant. Because you're really just saying, start at the origin and go 4 units in the negative direction along the y-axis. How far have you moved? You've moved 4 units. So the magnitude is equal to 4, right? Or the length. magnitude equals 4 here. So this is going to, when we compute kappa of 1, we're going to end up with 4 over, all right, well, we still need now the cube of the magnitude of r prime, but we can get that pretty easily over here. Let's see, magnitude of r prime, that's going to be the square root of, let's see, and this is at 1, of course. 2 squared plus 2 squared, that's 8. And then what do we need to do? We need to cube it. So if we cube this, we're going to get the square root of 8 cubed. Well, let's see, that's going to be 8 root 8. If you like to rewrite that a little bit, you can, but I don't want to. So I have 4 over 8 root 8. Of course, the 4 and the 8 will cancel a little bit, and you'll get 1 over 2 root 8. Again, you might say, oh, 8 is 2 root 2, so I could rewrite this as 1 over 4 root 2, and maybe just because you can't help yourself, right? And if you start rationalizing the denominators, man, now what are we doing here? What's the point? Anyhow, so this is a very straightforward problem in the sense that there's just a nice, well-defined formula for the curvature. You got to know that formula. You got to know how to compute cross products, magnitudes, etc. So hopefully this is helpful and clears up any misconceptions.